Hello all, welcome to part 2 of the Windows assembly language for hackers. In this video, we will look at what is protected mode very briefly and protected mode assembly in the context of Windows. Okay, so let's understand a little bit about the Windows environment. Basically, Windows runs with the processor running in a mode called protected mode. Protected mode actually enables the processor to do a lot of interesting things, and using this capability, the operating system is able to go ahead and allow for paging, virtual memory, and even safe multitasking, which was not possible in real mode. However, it is important to note that the processor first starts up in real mode and then switches to protected mode. Now Windows runs entirely in protected mode, and in the rest of this video series we will focus on 32-bit assembly on Windows operating system. In the end we might briefly look at 64-bit assembly as well. Now we will revisit protected mode and a lot of interesting things such as how segmentation, paging and a lot of other interesting things work a little later, probably in this series or in other series like how to write rootkits, etc. Right? As and when required, I will revisit some of these concepts. Okay, so programming assembly language on Windows. Now, as one can imagine, to go ahead and program any language, you would require some sort of a tool which will convert the code into machine understandable actual program. Now in the case of assembly language, you require what is called an assembler, which actually takes your source code, which is written in assembly, and assembles it into an object file. And then you have what is called a linker, which will take those object files, various libraries you are referencing, etc., and actually produce the final executable code. Now the most popular assembler for Windows is called MASM or Microsoft Assembler. As you may have already guessed, MASM is provided by Microsoft themselves. You can download version of MASM from Microsoft's site, and recently I think from Visual Studio 2005 onwards, it almost comes bundled with that exclusively, right? The latest version of MASM as of this video series is probably 9 from what I remember. MASM is also bundled with various other development packages like MASM 32, which we will look at in a later video, probably the next video actually. One of the unfortunate things about MASM is that it is closed source. That means there is no way we can modify the assembler and add more directives and things like that. Right? Also, one of the most important things to note is that the Microsoft assembler provides high-level language-like constructs which makes programming in assembly very, very simple. What these are, we'll revisit all of this a little later. Now, the only downside being that there is no default runtime library which is included with the assembler. And this is where packages like MASM 32 come to our rescue, which we'll look at in the next video. Okay, so I always believe that with every video there should be some practical, or else you're going to be bored to death. So now in this video we will once again go and create a simple hello world program in assembly, but now which runs in Windows, and then we will assemble it using MASM and then link it using link.exe. Right, so let's look at how we can do this. Now, as mentioned previously, you can download MASM from Microsoft's website. I leave that as an exercise to you. Right. So now I'm in my familiar DOS prompt, as you can clearly see, and we will go ahead and do this entire example within the DOS prompt itself. Now I will invoke an editor which comes bundled with Windows called edit and give it the name of our file, which is hello, let's say world.asm. Now this opens an interesting little graphical editor within Windows. Now in this exercise, I would encourage you to type along with me. The source code listing is not provided separately. If you're already familiar with basic assembly on Windows, you can skip this, else really would encourage you to type along with me. Right? Okay. So I'll just type on a couple of lines and then I'll explain what those mean. Okay, so the first line actually is a processor directive which tells, the assembler directive which tells the assembler for what family are we programming. So we are actually going ahead and telling it to use the assembly language for the 386. The second line actually tells it the kind of model to use, which is the flat memory model, and the way in which different APIs are going to be called, which is std call. What this actually means is we need to push the parameters right to left for the functions to work. We'll look at this just in a minute once we start typing the code. Then we basically give it an option case map none. What this directive does is basically ensures that all the labels which we are going to use are going to be case sensitive, which means hello with a small h and hello with a capital H are different labels as recognized by the assembler when we give it the source code. Right? So now let's move on. Now we need to actually define some data. The dot data actually kind of tells the assembler that this is the start of the data segment. Now here is where we are going to go ahead and enter our string. Let's call our string hello world. Actually, let's just write something else. Welcome to securitytube.net. I think if you followed the assembly language primer for hackers, you would be familiar with what is DB, which is defined byte, and why we go ahead and define it like this. There's hardly any difference between what we did for the Linux version and this one. So I'll leave this as an exercise to you. If you're confused about what this is, well, you need to go and look at the Assembly Language Primer for Hackers video series on SecurityTube. Now, what we'll do from here on is actually define the code segment. This is where our executable code is going to be. And we define a label called start, which is kind of like the main function. And here, what do we need to do? Well, we need to go ahead and print hello world in a message box. Now, in order to do that, of course, we need to use some of the built-in APIs of Windows which allow us to create all these visual boxes and have the message inside it, etc. So for this, we need to refer to the Windows API, which is available for free on MSDN. Now, the function we will call here is message box. Here are the inputs. The first is a handle to the owner of the window. Now, in this case, because we really don't care, the parameter is null because there is going to be no real owner of the window. After that, we go ahead and give it the message to be displayed. This is basically welcome to securitytube.net. And then you also have the dialog box title. Right? If you give it as a null, the default would be an error. So let's actually also define our dialog box title. Call it title db our first message box, right? Now let's come back here. Now what we need to do is go ahead and set up the registers appropriately and call this function. Now we need to push all the inputs from right to left. So let's look at what the other things are. So one of the other things is the type of the dialog box. Now let's go ahead and give it the default, which is MB_OK, which will just have one push button, which will just say OK. This is the default anyway. And for that, the fourth value, that is U type, needs to be 0. Right, so let's do the following. Let's go ahead and move the value 0 into EX, right? Now this needs to be first pushed onto the stack. Now let's look at the second argument from the right, which is the actual caption. Now the caption is basically title. So what we do is we use the LEA command, which is load effective address, if you remember from the previous primer video series. And what we are going to do is we'll probably use the EBX register and load this onto EBX. Then let's push this onto the stack as well. Right, then we have the actual text, which is the hello world string. Let's go ahead and load the effective address onto EBX again. And push this onto the stack. Then finally we have the handle, which is going to be null. Null, if you think about it, is nothing but a 0, right? So we go ahead and push EAX because we already have 0 onto EAX. Now we need to call message box. Now if we scroll down, what you would notice is that we have two choices. One is to call the Unicode version and the other is the ANSI version. Now in this case, we'll go ahead and call the message box A. It's because right, so let's say call have message box A. Right. Now there's one important thing at this point is the calling conventions. Now when we are using std call, there is a name decoration convention which we need to keep in mind. Now typically the function name is followed by the @ sign followed by the number of bytes in decimal in the argument list. As an example, for a function int func int a double b, the decoration is as follows, which is size of int plus size of double, which is 12. Right, and that is why we call this underscore func @ 12. Anyway, we can leave the underscore part. Now let's go back and rename the function. If you go and look at message box, if you look at these inputs, well, all of them are actually 4 bytes in size. So this makes the total 16. So basically, we are going to actually call this @16. Now, after printing the welcome to securitydtube.net, we basically want the program to exit. For that, we are going to call the exit process function with the exit code. Now we can have the exit code to be 0. So let's push 0 inside, which is what is contained in EAX, and then let's similarly call exit process. We give it the @ sign, and because it's an int, well, this is going to be 4. After this, we'll go ahead and end start, which actually shows that the block of code has ended. Let's save this file. Once we've saved this, let's go ahead and exit this program. Now let's try to assemble it. To assemble it, we'll use MASM, and if you've installed it properly, you can just invoke it using the ML command, right, the Microsoft assembler. Let's give it the center stage. Now, in order to assemble this file, let's look at the various options we have. The /C is for assembling without linking. This is what we are interested in at this point. And the output, which is going to be the object file, we would like it to be in the COF format. So let's call ml/c/cof and the name of the input file, which is hello-world.asm. And you'll notice something interesting. Immediately, we actually go ahead and get an error. Right? Errors in line number 14, 19, and 21. Okay, undefined symbol. Let's actually go back here. So it actually says message box and exit process. Both of them are undefined, and there's some syntax error on line number 14. So can you locate the syntax error in line 14? For that, let me come to an important concept. Till then, just look at line 14 and figure out what has gone wrong. Now, one of the important things is when assembling, Microsoft Assembler has no way to figure out where message box A is defined or where exit process is defined, as both of these are not really part of the code anywhere here. Because of that, we use a directive called extrn, which basically says that this is external and we are going to go ahead and take care of it while linking. So we go and use the command extrn, then the name of the function, message box A @16, and then we actually say that this is a proc or a procedure. Let me complete this as well. Exit, and now if we try to assemble this again, what you would notice is that the below two errors have disappeared. Now let's go back here. Okay, so the issue seems to be with the word title, right? So one of the usual suspects, till the time you're actually not very sure about each and every directive, is to ensure that there is no such directive called title. And if you note, seems to be that there is a directive called title. And this is what is causing the problem, right? Because you cannot use something which is reserved by the assembler. So let's go back, just quickly modify this to message title. Go back here, modify this to message title, save it, exit this, and then again go ahead and try to assemble it. And now if you notice, perfect assembly. And if we actually do a dir hello world star, actually notice we also have an object file. Right? This is what is the output of the assembly. Now, after assembling this, we need to go ahead and link it. For that, we will use the utility link. Tons of options. The most important here is to first choose an appropriate subsystem for linking. Now in this case, we are running a Windows application because we are calling message box A, etc., which are part of the Windows environment. Along with that, what is very important to notice, we need to link with the appropriate library. How do we figure which libraries we need to link with? Well, we are calling two functions. One is message box A, and if you scroll down, it will actually say that the library required is user32.lib. And then we also have exit process, and the library required here is kernel32. So we need to go ahead and link with these two libraries. So we can call the link command, give it the first directory, which is the subsystem. In this case we have Windows. Then we use something called default lib. First give it kernel32.lib and then give it default lib user32.lib and then finally give it the name of the object file. Right? No errors, no nothing. If we go back, now we will notice that we have a hello world.exe which has been created. Awesome. Now let's go ahead and run this hello world.exe. And if you notice, we have our very simple assembly language program. Welcome to securitytube.net, and the title of the box is our first message box with the OK prompt here. Just click OK. And we are done. It's very easy, of course, to go ahead and modify this program. Right? And we could go ahead, change anything we want here. One of the interesting things to change, if you actually go back to the definition of message box, is basically the kind of box, right? So would you like to have OK and cancel both? In this case, the value needs to be pushed is 1. So we can go back here and in type we need to basically push the value 1. Of course, after this we need to once again make EAX 0, right, so that the rest of the code is unaffected. We can save this, exit. Let's go back and assemble this. Let's then go ahead and link it. Where's our friend link? And now we can run it. And if you notice, we basically have OK as well as cancel, right? Anyway, so that's, I guess, most of it. Hopefully you should have followed me along each and every step and tried this out yourself. Let's go back to the slides now. Okay, so basically we can refer to MSDN or actually download the Win32 API documentation. Now, one of the key things that you've noticed is we have a couple of issues, right? Now, one of the the biggest pain point seems to be that we had to ourselves define a lot of these constants and other information, such as MB underscore OK and MB underscore OK cancel, right? We basically fed in the raw values. Now, this is not a very good programming practice, as you are aware. We need to probably statically define this somewhere else and actually use a label to call it. Right? That way we are sure that we are not plugging in the wrong value. It's very easy later on even to debug the code. This is practically unreadable. Apart from probably the hello world and the message title label, it's almost unreadable. Right? So what we are basically looking at is there is a problem here because we do not have any type of runtime library support for MASM, where a lot of these constants and important values, etc., have been predefined. So this is where we need to use some sort of a library. And MASM32 is a library and to be honest, a full runtime environment which is woven around MASM compiler by Microsoft. MASM32 is available on the website called masm32.com, I think. Oops. Right, we can go ahead and get MASM from here, can download it. And we will use this for our later videos. Hope you you had fun, definitely try this out. And please leave your comments and feedback behind. This is what keeps me going. So really looking forward to it. Thank you.